financial management for CPA, likewise fundamentals of finance for HED level. And right now, I want us to look at a topic known as risk and return. Starting from that point, risk, it is the possibility of not getting the expected return. When you fail to get what you wanted, this is what we call the risk. And in financial management, there are two types of risk. One of the risk is called systematic risk. And basically, these are risks that affect everyone in the industry. It's a risk that will affect each and every player in the industry. Example of this type of risk is economic instability. Another example is political instability, etc. And basically, this type of risk cannot be managed through formation of portfolio. Portfolio is whereby you invest in different areas. You have different securities. So this risk is not diversifiable, and we also call it non-diversifiable risk. The second type of risk is known as unsystematic risk. And these are risks that will affect the individual company. This risk affects individual company. It does not affect all the companies in the industry. It affects individual firm. Example of this risk is employees strike. The employees of company A, when they go on strike, that doesn't mean all the employees in the country have gone into strike. No, it is that individual company. Another example of this unsystematic risk is machine breakdowns, etc. Now, there is a way in which you can combine the two risks. We can represent them on a graph as shown below. We can draw a graph like this. We call this y-axis. We call this x-axis. Here, on the y-axis, we record the risk. X-axis, we record the securities, the number of security. Now, there is a horizontal curve here, and as you can observe, this horizontal curve, the risk is constant. The risk is not changing despite increasing security. And this is what we call the systematic risk. This area, it is systematic risk. While you can see it is not reducing, it is not changing despite increasing securities. Then we have another risk here. It is start from up, then it is left down like that. So it is started high, but as the securities increased, this risk reduced, and that is the risk we call unsystematic risk. Unsystematic risk. That is how we present the two risks using a graph. All right. Let me Now, having presented that risk, now you can do an illustration to see how you compute the various risks. And remember, risk is being computed using the standard deviation. I want us to do an illustration here. Illustration, it is CPA examination done under kasneb. This is CPA December 2022. Question number 2B. And the question reads, the following information related to securities X and security Y return for the year 2021. And for those who don't have the paper, let me write the question here. Here we are being given probability. We have the probability. We are being given return for security X and return for security Y. We have been given equation and we are being told return for Y is equals to 6 plus 0.2 return for X. Alright, my first probability is 0.1 against the return of 30. We have 0.2 against a return of 20. We have 0.4 against a return of 15. We have 0.2 against a return of 10. And we have 0.1 against the return of negative 50. Let's compute now the return for Y. And return for Y, we have been given an equation here. It is 6 plus 0.2 return for X. Meaning, for the first one here, I will take 6 plus 0.2, then return for X, which is 30. I get it there. 6 plus 0.2 plus 30. That's around 12. The other one is 6 plus 0.2, 20. That's around 10. We have 6 plus 0.2, 15. That's around 9. 6 plus 0.2, 10. That's around 8. 6 plus 0.2, negative 50. Negative 50. That's around 0.4. 6 plus 0.2 of negative 50. That is negative 4. Very true. It is negative 4. So those are the respective return for Y. Then question Roman 1 requires to determine the expected return. Expected return for security X and security Y. So this is how we compute the expected return, and we use the simple bar R. The expected return is given by, we take probability 1, return 1, probability 2, return 2, probability 3, return 3, and the process continues. So, when it comes for the return of X, this one is given by, we take probability, so we are multiplying probability with the return. Probability, return, probability, return, probability, return, probability, return. Let's do it perfectly. Take 0.1 times 30 plus 0.2 by 20 plus 0.4 by 15 plus 0.2 by 10 plus 0.2 by negative 50. That gives me 10. So 10% is the expected return for security X. We do the same for security Y. So expected return of Y is equals to, we take probability times the return. Probability, respective return. Probability, respective return. Let's multiply. Take 0.1 by 12 plus 0.2 by 10, 0.4 by 9, 0.2 by 8, 0.1 by negative 4. Remember this return was negative, so negative 4. I'm getting around 8%. So those are the expected return. So when you hear expected return, or when you hear of the word expected, know that there is a probability to be used. Yes. Let's go to Roman 2. Roman 2, we are being told to determine the standard deviation for each security. Now, when we talk of the standard deviation in our it is also known as the risk. If you are being told to compute the risk of each security, you are being told to compute the standard deviation. It is one and the same thing. And this is given by the square root of variance. Square root of variance. And this is how we compute variance. We use the formula. Variance is equal to the summation of probability into bracket return minus expected return we square. What do I mean? I mean you take probability into bracket return minus expected return of that particular security you square, and you continue with the process until the last probability. So I'm going to take 0.1. Let's go together. Take 0.1 into bracket 30, this 30, minus the expected return of x is 10 and it will not change. So minus 10 square plus probability 2, which is 0.2 into bracket 20 minus 10 I square plus 0.4 in bracket 15 minus 10 I square plus 0.2 in bracket 10 minus 10 I square plus 0.1 into bracket negative 50 minus 10 I square. I'm getting for 30, my variance for x is equals to 430. So my standard deviation, it is the square root of answer. I get 20.74. 20.74%. For security Y, I do the same. Security Y, I do the same. I'm going to take probability into bracket 12 minus the expected return of Y, which is 8, I square plus 0.2 into bracket 10 minus 8 squared plus 0.4, 9 minus 8 squared, and the process continues that way. Let's do it very fast. 0.1 into bracket 12 minus 8 squared plus 0.2 into bracket 10 minus 8I squared plus 0.4 into bracket 9 minus 8I squared plus 0.2 into bracket 8 minus 8I squared plus 0.1 into bracket negative 50 minus 4, and remember, it was minus 4, but I'm getting negative 4 minus 8 I squared. I'm getting 17.2 as the variance. Now get the square root answer. We get around 4.15%. So the third division of this y is equals to 4.15%. That is the risk of y and risk of x. From there, Roman 3 of the question need us to compute the correlation coefficient. Now correlation simply, it indicates the relationship between the two securities. And correlation can either be positive, negative, or zero. When correlation is negative, it means that the two securities are not being affected by the same risk. The two securities are not affected by the same risk. And that is the best correlation. When it is positive, it means that your securities are being affected by the same risk, and therefore, by combining them, you are not minimizing risk, you are increasing risk. When it is zero, it means that the securities are not related in any way. They are not related in any way. Now, this is how we compute the correlation coefficient. We say correlation is equals to the covariance of security A and B. In our case, is security X and Y, or over the standard deviation of security A times standard deviation of security B. Standard A, standard B. So that is why I don't want to wrap this standard deviation for X and for Y, because I'm going to use it. So I'm going to use it. Let me first of all complete the covariance. This is how we complete covariance. Covariance is given by, we take the summation of probability, and the return for A minus expected return of A. Do the same for B. We take return for A minus expected return for B. And here we are not squaring. What do I mean? So I'm going to take my first probability is 0.1 into bracket. My first return for X is 30. I minus expected return of X, which was 10. The same. I take the first return for Y thereof, I minus its expected return. The process continues since the probabilities are many. So I add 0.2 in brackets. The second return for x is 20 minus its expected return, which is 10. Open another bracket. For y, I take 10 minus 8. The process continues. The process continues now. We take 0.4. Its return is 15 minus 10. For y, it is 9 minus 8. We continue that way until we reach 0.1 probability, until we do away with all of the probabilities. So let's do together. Insert 0.1 into bracket. 30 minus 10, close the bracket, open another one, 12 minus 8. Then we add 0.2 into bracket. 20 minus 10, close the bracket, open another one. 10 minus 8 plus 0.4 in bracket. 15 minus 10, close the bracket, open another one. Take 9 minus 8. We continue that way. We continue that way until the edge. So do it that way until the edge. And we have said we are not squaring. We are not squaring. Instead, we are using the two brackets. And this is what is called covariance. We are combining. We are combining 0.2 bracket 10 minus 10, close the bracket, open another 8 minus 8 plus 0.1 bracket negative 50 minus 10 bracket negative 4 minus 8, like that. So I'm getting the covariance of x and y as 86%. 86%. Remember, we have done even this 0.2 in bracket 10 minus 10, 8 minus 8, plus 0.1 into bracket negative 50 minus 10, close bracket another negative 4 minus 8. Vile tu tumefanya kwa hizi, inaongezea tu the other two probabilities. Now from there, we are good. We can compute now the correlation. The correlation. So therefore, my correlation is equals to, I take 86, which is the covariance. Standard deviation of my x is 20.74. I multiply by 4.15, which is the standard deviation for y. Remember the formula for correlation is covariance A, B, that is 86, then standard A times the standard deviation of B. So I have my 86 in calculator, so I just divide by into bracket 20.74 multiplied by 4.15. We are getting 0.999 for approximately 1.0, and it is positive. It is positive, meaning the two securities are being affected by the same risk. And again, another thing to note is that the two securities is not a good combination. Another thing to note about the correlation is that correlation should never be more than 1. correlation of 1.5, 1, 2, 3, 4, 5, that is wrong. Correlation should be at most 1 and at least negative